What's up, what's up, what's up, what's up? Welcome back. Today we're kind of working on my Git GUI. So I'm writing a Git GUI. There are reasons for that. I want to write one. I'm not going to go into why this stream. And one of the many things that this Git GUI does is it like shows diffs, right? And I wanted to control the diff generation process because at some point I might want to look at like trying to make some sort of like syntax aware diff or something. I might want to like, I want to track moves. There's like stuff I want to do. And so having control over the algorithm is great. But what I've got right now is something that runs in n squared space, where like n is the number of lines in the two files. And what that means is that the diff algorithm is actually taking like a metric fuck ton of memory, right? So like if I limit this down to like 25 megabytes ish, like I can't even generate what is like a diff for like a simple file, right? If I look at like how large is this like libdiff source librs, I can look at libdiff source librs, and it's only like 1,000 lines. So needing 25 megabytes for 1,000 lines is insane. And as we get up to like larger and larger files, I've seen files on my disk where the diff fails to generate because it goes like, holy shit, I need 360 gigs of memory to do this. And so the question is how do we improve that? Well, we're using this like diff algorithm called Myers diff algorithm, and he wrote this paper, and it's kind of like the diff that everybody uses as far as I understand. And he works in ON squared space, but there's like an optimization you can do to make it run in linear space, but there's like some trade-offs doing that. That's why I didn't jump there right off the bat. And so what I want to do is I want to implement the linear version, but before I do that, I want to have some sort of sane visualization. One, because I think that implementing something like this on stream without any visualization is just like, it's going to be impossible to like convey what's happening. Like it's just going to be hard for me to explain to viewers what's happening. And also like I'm only like 70% sure that I understand what's happening, and so visualizing it step by step is going to be very helpful for my own understanding as well. So I think approximate plan of action is let's look at the initial algorithm. So this is the algorithm in the paper, and he's like some for loops, right? For step in this thing, for step in that thing. We'll get into like what each of these means later, but it's like a double nested for. And if we want to visualize that step by step, then we need to be able to pause the algorithm at any given step in this process and look at the state of him at that point. So this step one, take our like double nested for, turn it into some sort of like state machine that we can iterate and pause when we want to. Then step two is to like find some way to present current state on in some GUI of some form. And then step three is like show progress. So what is Myers diff algorithm? Okay, imagine you have two strings. You have like well, let's use the ones in the example from the paper. A, B, C, A, B, B, A. A, B, C, A, B, B, A. And you want to know how to turn that into, well, let's look a little bigger. You want to turn that into CBA, BAC. CBA, BAC, yeah. A, B, A, B, B, A. A, B, C, A, B, B, A. Yeah, okay. So this is the diff that we're trying to generate, right? So we're trying to go from 1 and turn it into 2. So you can kind of like imagine the total number of things that you can do on like a 2D graph like this. So the idea is that you have to traverse, you're trying to get from like the starting point, the top left corner, down to the bottom right. And each traversal horizontally is like looking at a single item in the first element, and each transition vertically is like looking at an element of the second string. And the idea is that you have to look at every element in both items in order to determine the edit sequence, right? And so what this is representing is every time I move rightwards, it's like I'm deleting a character from the first thing, and everything I move downwards, it's like I'm adding a element from the second string. And when I move diagonally, it's like, okay, they were the same. So the idea here is if I start with like ABCA, BBA, and I'm trying to get to 2. In order to do that, I can say, well, I have to delete A, I have to delete B, then I have a C that's here, so I don't have to do anything. Then I need to like add a B, then there's an A already here, there's a B already here, I have to delete the B, there's an A already there, and then there's a C. That kind of thing, right? So you're slowly kind of like transforming the first thing to the second thing. And so they represent this as like this 2D graph, and there are diagonals on this graph whenever the two characters are the same, right? So you have like, if I have C is equal to C, then I can do a diagonal move to get there. Right, so like here, where are these diagonal moves coming from? So here he's saying that like A here, there's a diagonal. B here, A here, diagonal. I'm not really quite sure. This doesn't look like how I saw it in this other version here. So he's going from, oh, I see, yeah, C, right. So B and B get a diagonal. A and A get a diagonal. That's right. Yep. Okay. So I think what I want to do is I want to draw a graph like this and kind of show as we traverse the graph in the algorithm where we are in this visualization. And the kind of trick here is, let's see, maybe in this page. This is also, by the way, a very good blog post by James Coughlin, whoever that is, but he kind of goes over like the whole algorithm. But the idea is that basically diagonal moves, you represent those as like free moves, and if you represent those as free moves, you can basically turn this into like a breadth first search, where you're basically saying, well, I'm going to at each point check, like look branch, and see which way I should branch at each point, and trying to maximize diagonals, which I am poorly explaining because I don't really have a very good handle on it. But here he's kind of like, this guy kind of shows like generation of this tree. So he's saying that like, if I get to like this point here, the algorithm says you can automatically just propagate down to this point here. So if you're like walking this tree, you say, boom, oh, I see a diagonal, and it's like snakes and ladders. You just like shoot down the snake. Why is it called snakes and ladders? Why would you ride the snake? It is a snake, right? Yeah, it is. I don't know why I think I've also seen chutes and ladders, and it just seems like that makes way more fucking sense, right? You take the slide down or the ladder up. What the fuck is the snake for? Okay, sorry. It's like chutes and ladders, because that makes more sense. You like see the diagonal, you go whoop, all the way down to that point. And so the algorithm kind of ends up representing this in this like kind of clever way where you have these two variables D and K, and D is kind of like how many steps you've taken in this breadth first search, and K is kind of like where horizontally you are along the tree, right? So if you have like a tree like this is like D0, D1, D2, D3. And then K would be like where in this like diagonal you are. So K is like 0, 1, 2, 3, 0, 1, 2, 0, 1. It turns out with that amount of information, you can store basically like into like a clever representation of the problem. And then you just have to like find D and K, where K is the biggest number, like the desired end position down here. Yeah, that's kind of it. So, and then, then the last step of the algorithm is, you have to, once you have found like the path that you're walking, you now know like where the end is, but you have to remember every single step you took along the way. And that's where like the n squared comes in, is that at every layer, you have to remember all the things that you did so that you can walk backwards at the end to figure out where to go. Like which path you took to get to the end fastest. Okay, so let's look at this algorithm and state machine it. So it's nothing too crazy. It's like for D in 0 to like max distance, where max distance is like the length of A plus length of B, like the two things that you're diffing, the length of each of them. You do this like you iterate over each potential spot in the branch, and then you do some like checking to say, okay, well, if I look at like my last iteration, what were my values and which ones are bigger, essentially, like which one gets me to farther along this tree, and then you pick that one and then you go again. That's basically it. Okay, so let's look at libdiff. So here somewhere, this is where I've got it implemented. And I guess what we have to do is we have to make some struct. Diff algo, we'll call it. And he's going to have all of the things that we were using in this loop, which I think are the trace, where we're like remembering all of the steps that we took. He's probably got he's got to remember the max distance, which is a usize, how many steps that we're allowed to take. And then he's got to remember like D and K, which I think are I64s in this case, which means that max distance should probably be an I64 as well. What else do we need? I guess nothing, really. Maybe, we'll find out. Okay, so he's going to have some sort of implementation, and it's going to say impl diff algo. And we're going to have to create like a new thing. We're going to have to like initialize him in some way, which probably should just take the inputs to the diff function. Probably. And he is going to return a diff algo, which is essentially just going to be something like this. So he gets, I guess this thing can fail. So we're going to say, here is how you can fail, and then we just put the thing in. Okay, max, okay, diff algo. And I guess we probably have to store like the data that we're checking as well. That seems very likely. Very, very likely. And these are going to have some sort of lifetime A, so we have to put those in here as well. And we need comma. Okay. So now, what are we doing here? We're looking at, we store the max distance, we store the trace, we set D to 0 and K to 0 initially. And then we store A and B. Solid. And so now this guy needs to say, well, I'm going to do it for some A and U. And we have to return those here. Okay, which means that these guys have to be associated with that lifetime. And we're chilling. Okay. So now we have to say, what are we going to do in each step of the algorithm? We kind of have to like break out these loops. So we have for K in the negative D to D. So I guess that's like the inner loop. And in this inner loop, we can replace the for loop with just like the condition that he is trying to check. So we'll say if K is equal to greater than or equal to D, we return for now. We're only gonna we'll handle the outer loop later. Maybe we'll even call this step inner so that this like return will make sense. Okay. So then at the end of this, they're doing this like K in negative D to D step by 2. So here I guess we say K plus equals 2 at the end. And then we can just do everything in the inside of this section, probably. And this should be self dot. And we just have to look at all of the places where it's complaining. And slap some selfs on there. Self, 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 self. 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 Yep. Self. And self. Self. Okay. I guess D is also self. Bum, 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 bum. Everywhere, everywhere. We throw some selfs in front. Here, here, here. Okay. A couple more. A couple more. Here, he's kind of saying, I'm complete. So maybe we'll return, in this case, if we are successful, what is the shortest at a distance? Because that's an important part. That's like basically like how many steps did we take in the algorithm, because that's where the tree is valid up to. So here we can say, at this point, I guess we don't need to return anything, because we already have that kind of encoded in self.d. So here we can just say bool. If it's true, we are finished. So here we will return true, and here we will return false. I guess there's actually 3 things that we have to do here. There are 3 things. One is increment outer loop, one is finish, and one is increment inner loop. So I guess here we're gonna say like enum diff algo inner action, I guess we'll call it. And we'll say either there's nothing to do because we handled it, or we're finished, or we are going to step outer loop. Yo, what's up, what's up? And so that means that here we can just say this will return some sort of action, and in this case, the action is step outer. In this case, it is diff algo interaction finish, and here it is diff algo interaction none. We handled it. We did everything we had to do internally. We forgot to throw some selfs on here. Yep, these are member variables, and he doesn't like this now. What's he bitching about there? We probably have to put some constraint on you. Operation equals equals cannot be applied to type use. Yeah, so we have to say that, hey, for this to work, we need you to have partial equal, which is chillin'. Wonderful. Okay, now I guess this outer thing in the loop doesn't actually ever do anything. So we can actually say here, if self.k is greater than or equal to self.d, we can actually just do this at the bottom. So we can say we're either stepping by... I guess we'll step by 2 at the bottom, and we'll say on the next version of the loop, iteration of the loop, if we are greater than d, then we'll say self.d plus equals 1. And self.k is equal to negative self.d. And that'll reset it, and then we don't need this like step outer thing. That's gone. Which kind of means that this is just kind of step in general. And maybe this should be done at the top as well. This has to be done, it can't be done at the top because on the first iteration of the algorithm, we have to do k at 0 first. Okay, okay. So I guess that's possible that this is ready to go, to be honest. I kind of thought that would be harder. And it might be harder because we don't know if we're done yet. But we can check if we are. So we can say we have this like initial thing. And we can, instead of working with these like local variables, we can say let algo is equal to diff algo new with these inputs. So A, B, and max memory bytes. And then here, instead of doing this loop, we can just say while algo dot step is not equal to diff algo interaction finish. We just continue on, and so all of this should go away. And then we just have to kind of translate this stuff back into like local variables. So shortest edit distance would be algo.d. This guy probably needs to derive partial EQ. What are we doing? We are trying to write a visualization for a diff algorithm. So right now we're translating this like double for loop thing into like a state machine that we can look at the progress of. And then once we have that, then we can like build a GUI around like stepping through the algorithm step by step and looking at its current state. Okay. So this guy's using some other local variables which seem like they shouldn't be valid anymore. So let's kind of pull this guy out. And we'll say let trace is equal to algo trace. And he needs to be mutable, I guess, even though we're not modifying him anymore. So this half of the algorithm is like the backtrack section, and this part is the forward pass. Looks like max distance isn't used here. And what we can do here is we can run cargo test, and if this passes, that means that like our translation did the right thing, because we now have all these tests that are trying to do a diff already, and if they're not broken, then we translated it correctly. Which it's not. It is complaining. So we fucked something up. Big time. Big time. Which is annoying, because I don't really understand why. So it looks like nothing's crashing. And let's see how stupid it is. So he's got insert, remove, traverse. We've got traverse, remove, insert. Yes, it's just like taking the wrong path. So I guess what probably makes sense is to compare what we're doing with what was originally being done. Let's just double check also that like we're not using any local variables that we shouldn't have been. So this guy, max distance, okay, diff algo new. He's got max distance is calculated the same, but maybe we don't pull this guy out here. And we just say if algo max distance is equal to 0 here instead, which shouldn't matter, but I just want to kind of reduce surface area of things that could be wrong. And then it looks like no local variables are kicking around in here from before the algorithm finishes. So probably what makes sense now is we should probably like pick a test, like a single test that's failing. So we'll maybe look at swap elements, which, if I remember correctly, is just, hey, we have 1, 2, 3, 4 and 1, 2, 4, 3. There should be a simple swap in there, and we can kind of like log behavior in this version and before and after our changes, and that'll give us a little bit of a clue. So let's say that we have D is here and K is here, and we log them as self.d and self.k. Oh, I already see the problem. This is supposed to be a greater than, not a greater than or equals to. But let's just finish up that log just in case. Yeah, okay. I think that fixed it. Just a classic off by 1. Okay. So luckily we don't have to go through that logging hell. And that is the forward pass kind of split out. I don't like the name of this. This should be diff algo action. And I guess the fact that he's only finished or none kind of indicates that I could just use a bool there. But, you know, there's an argument that bools are sketchy in this kind of like what true and false means is not clear, but an enum with names is clear, and this could compile down to a bool anyways, so maybe it's fine the way it is. Maybe it's fine the way it is. And let's think about, is this enough to start visualizing something? Because I guess let's at least pull out this code to reverse the path. So what are we doing in this like backwards pass builder thing? We are saying I see. So they're kind of going to like the bottom right corner of this like edit graph, and they're saying, hey, I can figure out what like D and K were that you were using to like do this iteration from that bottom right. And now just like let me look at the data that you logged, and I will just like do the same thing that you did when you were going forwards, except I'm going to do it backwards, and instead of trying to figure out which path to take, I'm going to try to figure out which path you did take. And I see, yeah, for each of those things that we do, I'm going to say what happened. I'm going to write down what happened. So if we want to visualize what we have right now, this is probably enough to visualize the forward path, but not the ideal path. Or like it'll show us like each state. It could show us each state, but not the full path. But that's okay. That's enough to get going. So I think that makes sense to start probably working on a visualization. So we'll kind of say take diff algo forward pass here. And then we'll kind of like loop back at the end for drawing backwards pass as well. Draw backwards pass, not drawing. And I should have written the time here. I don't know why I didn't. But that's okay. Okay. So let's say that it is time to split out a new project where we use this diff algo structure. And we will use it to draw something. So I guess he's going to have public function new, public function step, and eventually he's going to have some form of, like data extraction API on him. But for now, we will just start with this and we'll see where it goes. So I think probably we have this like workspace where we have like our diff tool in one area and this like diff library in another. And so maybe it makes sense for us to have a third project, which is like diff viz, we'll call it. And he is going to go do cargo new or init bin. And this will create a diff viz. And I think, how does like dependencies work in this guy? We have libdiff is equal to up a directory path. Okay. Sweet. And our workspace has to say that we have to have a diff viz in our workspace. Yep. How did that diff viz already get up there? Am I high? How did this get here? I don't remember writing that down. Maybe, oh, cargo init must have done it for me. That's clever. Clever. Okay, and in here, let's just say that we are going to go into diff viz. And we are going to use diff algo from libdiff. And for now, what do we want to do here? I just want to like construct the algo with some things. So we're going to set a max memory usage of like 100 megs. And let's just say that our A is going to be like 1, 2, 3, 4, and our B is going to be 1, 2, 4, 3. Okay. So these guys to be borrowed. And then let's start by doing a while algo. We'll do a loop. While algo dot step is not equal to diff algo action finish. There we go. So that should run the diff. Here we need to unwrap this guy. And this needs to be mutable. And then we can maybe print line the algo state at the end. And we'll call it done, which means that this guy needs to derive debug. Okay. So Myers trace cannot be formatted with debug, which is fair. I guess we'll just say derive debug for now. And okay. So it looks like we populated some data in the trace, but it's not very clear what this data means, but that's okay. We'll get there later. Yeah, it looks like we have something to work with. I guess next, let's get some sort of GUI up. So let's add eFrame, which is eGUI toolkit wrapper thing to make my life easier. And let's get a window up. And I like cargo doc open. How expensive is this? 490 crates. Can't be that bad. Let's see how long this takes. It's slower than looking up the docs online, that's for sure, but only the first time. And it would work if I had no internet. But I wouldn't be able to stream with no internet, so it doesn't fucking matter. But, you know. Let's give it a sec. I believe in him. 405. We're almost there. Come on, buddy. You can do it. There we go. No diff algo action in root. Private struct diff out. What? Am I high? I thought I made it public. Pub? What's it complaining about? It must be using some sort of like out of date. There must be some like caching problem in here, but we at least should have eGUI eFrame. We should have at least docs for the crates that I care about. So I can go open this guy. There we go, and we can look for. Here's this example setup. Usage. So it's just kind of like yoinkies. Yoinkies. And we go into main again, wherever we were. And just kind of slap this guy on here. So we'll take the code that we had before and we'll shove it in here for now. And cool. So if I run this, we should get some sort of window up. Cool. And probably what we want to draw is we want to draw the A and B things that we're diffing on two axes. Yeah, makes sense. I can't remember if this app creator requires static. He requires boxdine app where I guess we'll see. I don't know like if I can pull in references to stuff from outside here. We can try it. So we can say A is a list of I32s and B is a list of I32s. And we can say A and B here. And this guy can have a reference label stuck on him. He has A, which is a bunch of I32s, and B is the same. That probably shouldn't compile. Cargo build. Blocking. He's waiting for somebody to... Somebody's thinking, and he's got to let him go. Probably my language server. What the fuck is taking so long? Nobody's even using CPU. What the fuck is happening? Okay, there we go. Finally got there. So we need to say this guy has some associated lifetime. Wonderful. And these guys need to have little ampersands on them. Yep. And this guy also needs to have a lifetime association with them. Cargo build. Borrowed value does not live long enough. Aha, so this guy does require static lifetimes. Which is a little annoying, but not the end of the world. We can just throw these guys in some arcs. Arc. New. Womp womp. I think these have to be arcs. I'm assuming. Well, this might run on the same thread. We'll try RCs first. We'll see what happens. So it's like RC, RC, I think. And then here we'll say that we're storing shared reference to a bunch of I32s. I think like this. I think that's something you're allowed to do. And these guys take in A and B like this now. And we can't use default anymore, but we can construct him. So these guys are going to take in RC I32. There's going to be RC I32. Finally caught a live stream and don't have to watch YouTube. Hooray! We made it! This guy doesn't have to have a lifetime associated with him anymore. Yep. And this guy is just going to say my eGUI app with A and B. Okay. Are we chilling? Looks like everyone's happy. Do I need to write as ref here? Yes, I do, for some reason. But works for me, works for me. Okay, cargo check. Oh, fuck. Cargo build. I don't know why. So there's something wrong with like the check state in here where it's like using out-of-date data, and I don't know how that happens. And I think I have to cargo clean to fix that. Can I cargo clean only the config stuff? Damn it, that sucks. That sucks. But I guess we'll make it work. Cargo check. I guess we can probably do this in the background. So let's just get a second window up so we can do it without having to pause. Okay. So what are we doing here? We're trying to draw what is essentially this graph here. So we're trying to show A on the top and B on the bottom. So I guess we are going to have some graph that's relative to the window size. Available size equal this. And this is a vec2, so we're going to maybe say like use eGUI self and vec2. And then here, I think that we can do something clever like vec2 x, y is equal to available size or something. Is that what I want to do? No. No, it's not. Let available size equal this. Then we can say like available size x is equal to window width and window height is equal to this. And what are we going to do with this? So I guess we're going to draw each element spaced out in some way, I guess. So if we have like a space like this, we're going to draw the first thing probably right up against the edge and the last thing right up against the edge. So it's going to be like 1, 2, 3, 4. Is like you're going to want like something like this, which means your first position is just 0. Your last pause is width minus window width minus render width, like of a single character. And then everything else kind of needs to be like spaced evenly. Probably it makes sense to render each of these guys up front one time, because we'll know they're never going to change. So probably here we're gonna want like, well, let's just render them all every frame for now, and then we'll figure it out from there. So let's only worry about the x-axis for now. So we're gonna say like for item in A, self.a, as ref, we're going to render the item. So we're going to say let rendered is equal to a vector. And for each of these guys, we're just going to say self.a, or item, to string. And I guess we're going to say like arc. How do I make layout text in this fucking thing again? So it's like in eGUI. Ah, fuck, I cleaned, so I don't have this. We'll just use the online docs. Fuck it. Fuck it. So he's got some sort of like layout text or something. Font layout, and this creates a galley. Yeah, okay. So we use some font to layout. And so we have to like request a font somehow. So we get like this like fonts thing, layout with font ID, which means that we need to like get the default font ID. So probably there's like some sort of like styling way to do that. eGUI, so we have like UI style. And this style must have like, he has text styles. The most convenient way to look this up is to use text style resolve. Okay. So we can get a text style. Let's use, I guess it doesn't fucking matter. Nice. Okay. So we can say text style monospace for now, I guess. I don't know, it doesn't fucking matter. Resolve, and we need to use text style here. So they're saying to use resolve with the style. Okay. So we pass in UI style like this. And now we have like a font ID. And then we can say UI fonts. We're going to do some stuff with the fonts. And that thing that we're doing is we're going to render the string with it. So we're going to say where were we? Fonts, layout. I guess laying out and rendering are slightly different, but we're going to determine the size of like the rendered text for each of these. Okay. Layout dot our fonts layout. No wrap probably makes sense. I guess we'll figure it out later. And the text is item to string. The font ID is the font ID that we got. And the color, we're gonna use like, I guess, is there like, why is this, can I just use optional, like, oh, is there like a marker for like, I don't give a fuck? Placeholder, this is invalid, blah, blah, blah. If I use placeholder, does that get angry? Fuck it, we'll just use the default. We'll look it up. We'll look it up. It's UI style default. Fuck, style. Just, what is it? For text color. Visuals, probably. FG. Text color. Here we go. Yeah. So it's UI, style, visuals, text color. There we go. Okay. So we'll call this maybe laid out. And then we can say laid out push this. And font ID, I guess we need to clone it. Or maybe can I take it as a reference here? Nope. Clone. Okay. So now we have these like laid out sections, and we just need to figure out like where to put them. So what's on a galley? For someone with a web dev background who wants to learn low-level systems languages, nothing but for personal pursuit, would you recommend starting with C, C++, C, or Rust? I think it totally depends. So in my opinion, low-level is not very different from JavaScript. Now that might be a very biased viewpoint, because I started with low-level and then started on JavaScript. But like I think like the idea of like you have functions and APIs that do things for you, and you have to call them and figure out what they do. It's like kind of like the same as just like using a library. So I don't think it's like that hard to get into. In terms of like what language, I think it's like personal preference a lot. I've never tried Zig, but I've heard good things. I've also heard it's not very done, which might not be true. C is I think all of these languages you're going to have to learn C. C is kind of like the simplest of them, and the concepts from C will make it into the rest. Like it'll kind of make everything easier, in my opinion. Like when I work in Rust, I often translate concepts into C concepts, but maybe that's just because I started with C. I think Rust has like a lot of stuff that is like you're going to have a harder time writing the code, but you're also going to get less frustrated by like crashes and stuff. You'll just get frustrated by other things. And I don't know how much I would recommend C++ in general for like in terms of like personal enjoyment. I think it's quite powerful and used in the workplace a lot, but I don't know if I like it. Like C, you're going to make a lot of mistakes and you're going to go, fuck, I'm stupid. And in C++, you're going to make a lot of mistakes and go, fuck you, standard library. At least in my experience. That's how I feel when I read C++, is that it's like, it's hard to blame yourself because there's just too much to know. Where C is like, there's no standard library C can't fuck up. So I'd probably start with C. That's a long-winded way of saying, I had to think about it out loud, but I think I would start with C. I would probably go C, C++, then Rust. Or like Zig could come after C as well. Like without any C. Like Rust is kind of like C++ on steroids. Zig is kind of like C on steroids. It's like my general understanding. And C++ is just like fucking stupid but useful. C++ is like C with classes, but it's not actually C with classes. It's like C with a bunch of shit. Okay. What am I doing here? I laid out some text, and now I want to figure out how to space it here. So I guess we're going to probably like special case handle either the first, the last, or both. So I guess we're gonna want to like figure out like how do we like determine how much space we want to use. So let's say imagine that each thing that we rendered was like infinitely skinny. He's been on a diet. He's been intermittent fasting so much that he's Flat Stanley. I think is that what it's called, Flat Stanley? But there's this book that I read when I was like 10, maybe younger, 8. Yeah, this guy, Flat Stanley. He's just some guy and he's like a piece of paper. What a weird concept. But anyways, so he's been dieting. He's Flat Stanley. How would we determine like where the center of each of these things go? So the first thing is at 0, the last thing's at the end. But what about like these guys in the middle? My gut says, say you take the last element out. Then or maybe you take the first element out. Then you can kind of say, this is how much space I need between each thing. So then if you, without the first element, spacing is width over num elms. So spacing in general is width over num elms minus 1. Okay. So we'll say let spacing is window width over num elms, which is a.len self a.len layout.len. Okay. Yes, okay, and this would be as f32, I guess. And this would be as f32. Maybe I do the subtraction first, then as f32. Then we special case the first thing. So we'll say, well, maybe we'll just left align these things for now because I don't really want to worry about it. Or maybe we'll just make a function. Function draw elem at position. And this is going to take in a laid out thing. So he's going to look at laid out 0. I guess maybe it makes more sense to do this as an iterator. Mute it is equal to laid out iter. And we're going to say, we're going to draw the first thing. And we're going to draw it at the position of 0. And we're going to have to stub out that draw element position thing so that the indexer is happy. Draw elem at position, and he's going to take in a elem, which is a arc galley, which means that we need galley here, which galley is like kind of like the laid out text, basically. And I guess we need stood sync arc as well. Okay. And his second argument is going to be a position. So position f32. And he's also certainly going to need like a something to draw with. So painter probably. Which means we have to import painter. Here we go. And painter. Nice. And probably this is going to be like this. And we'll just say here, let painter. It's UI painter. Okay. Yep. Okay. So now what we're going to do is we're going to iterate over all of the elements. While for elem in it, we're going to basically say we're going to draw at the next spacing increment. So let pause equals 0.0. I guess, yeah, that's true. That's correct. We're going to say pause plus equals spacing. And then we're going to draw element position. Yeah. But this isn't it next. This is just now elem. Okay. This has to be drawn at position, though. Which kind of means that you can just do this here. I see you lost Vim opt sign column equals yes from your config again. Oh, I knew somebody gave me the fix for that at some point. And then I forgot. I don't know how you deal with the gutter shifting every time. So the reason it doesn't piss me off is because it happens when I do something. It's specifically like, I think it's when I leave edit insert mode or something. And so like from my perspective, it's like I click a button and like my brain's already doing a context shift. So like the movement is just part of the context shift. But I can see why that would be like fucking annoying for anybody watching. You do the same thing, you change it in the session, but don't commit it to the config. Fine, I'll fucking do it. Vim o sign column equals yes, true. Fine. If you're gonna whine about it. Oh no, fuck. He doesn't like that. Invalid argument. Just to be clear, you should whine about it, and you are right to whine about it. Why doesn't it like that? Lua Vim options sign column equals true. vim.op.soundcom is equals yes. But I don't understand. Oh, maybe it needs yes. Maybe there's like other options. Ah, that's why. So it's not a Boolean thing. Okay. Config mvim init. Yeah. I thought I could get tricky. So this is sign column, and this is yes. Okay. There, okay. And what we're doing, we were in main of this thing, and we were laying out these guys, and they've been laid out. We just have to actually do the drawing now. So here we just say painter, like draw text or something. There's like galley. Yeah, so we take in a galley, we draw him at the position. Oh, with a fallback color. Oh, so we could have used color 32 placeholder back where we injected the color here. Not that it fucking matters, but we could have. Okay, so this is just gonna say painter galley, and we're gonna take the position of the thing. So we're gonna say pause 2. And I think there's like eGUI pause 2. Nice. And we can just take in pause on X, and Y we'll just put it at like, I don't know, 10 pixels down or something. I don't really fucking care for now. We'll fix the Y axis later. And the galley is the galley, and the fallback color is color 32 white or something. I don't care. It doesn't fucking matter. Arc clone this guy. And we have to import color 32. Okay. And I feel like pause 2 should come from here, not from ePaint. I don't know why I imported it that way. Okay, cargo check. We chillin'? Cargo run. So now, if we did everything right, we should see the numbers 1, 2, 3, 4 spaced out over like the whole visible area of the screen. We just gotta give him a sec. And probably the 1 and the 4 are gonna be rammed up too far against the walls, so we're probably going to want to like kind of put this whole thing in a frame that has some spacing around the side or something. Nice. That looks pretty good though. The 1, 2, 3, 4 sure are spaced out. Now we also have to handle centering the elements, but that's actually probably fine. That's probably good enough, to be honest. Since we're doing everything with this like painter, we also have to say, hey, I'm going to use this whole window. So here we'll just say available size. That way, like, eGUI knows. Not that it really matters right now, but that way eGUI knows that we're using up everything. Which is nice if you, like, put, like, a label at the bottom or something. Like, if you use any of, like, the built-in widgets, now they'll go in the right spot. Have you ever played with other UIs? I've only seen your series that use eGUI. Yeah, I've used, let's see, what do I use? GTK, Qt, like, web, IMGUI, but not much outside of that. Like, I found that, like, a lot of the Rust ones, like, eGUI is, like, the best option for Rust when I read them, and then I just, like, I like it, so I never look back. And Qt doesn't map very well to Rust, although you can make, like, C wrapper, like, you could make, like, a C wrapper API and then build a C++ app that does, like, the rendering and stuff, which is, like, a fine approach, but I don't really like Qt that much. GTK is, like, fine. I think GTK is, like, too tied to Linux. So this is one of those things where eGUI is what I'm comfortable with, so I just keep going. There's nothing like... It's rare to me that software doesn't piss me off, and eGUI never pisses me off. So, we'll just keep moving with it, I guess. Although, I guess it's good to try other things. It's good to expand, but it is what it is for now. Okay, let's put this whole thing in a frame. So, or maybe just like a smaller UI inside. UI allocate UI at rect. So can we take like the UI rect, max rect, available available rect before wrap. Seems reasonable. And we'll just kind of decrease, we'll kind of say, we'll bring everything in a little bit. So we'll say let margin is equal to const margin is an F32 equal to, like, I don't know, 10.0, 10 pixels. That seems reasonable. And we'll just, like, rect. How do I top? Does he not have, like, elements I can just, like, edit, modify on him? Why is my fucking cursor stuck? Okay, so this guy returns a rect. Do I not have... Oh my god, let me jump to definition! Thank you. Min and max, that's what it is. Okay. So we'll say rect min x minus equals, or plus equals margin. Y plus equals margin, rect dot max dot x minus equals margin, and y minus equals margin. Okay. And then we say UI allocate UI at rect. We use this rect, and we do everything that we were doing inside this guy. I guess the calculation of size needs to go in this smaller version. So that's this guy down here. Yoink. And now hopefully we have some margin around the side. I don't see any margin. Probably because these, like, painter positions need to be relative to the rect that we're in. So maybe we want, like, UI. We get the available rectangle that we're in. Or I guess we just can use the rect that we've asked for. And we can say width over this rect width. And I guess we can just use that directly. Let's see. So here we use rect width. And here position starts at rect dot left. Yeah, that's probably what'll do it. Probably. Okay, so 1 is a little bit in, 4 is a little bit to the right still, but let's see what happens if I, like, crank this up to, like, 30 pixels. Does 4 come in from the right as well? Yeah, it does look like that. It looks like it's, like, working to some extent, except the there's, like, kind of like some, like, weird offset going on in here. But maybe that's fine for now. I think we're rabbit holing on a problem that doesn't fucking matter. Okay. Let's draw the vertical thing now. So vertically, we have to how do I want to do that? So I guess here, this is going to take in a pause too, and that will make this simpler. And this guy is going to say eGUI pause 2. And we're going to use pause in 10.0, blah, blah, blah. And this guy needs to use eGUI pause 2, pause in 10.0. And then we need to draw, we just do the same thing here, where we iterate over, this is going to be called, I guess, X laid out, or A laid out. And we're going to do the same thing for B, which kind of indicates that this should be a function that we pull out. So we're going to say function lay out elms, and he's going to have an elm, which is a I32 slice, and he's going to come back as an arc galley, which means he's going to be in a vector because he's got many of them, and he is going to take in a UI, which means that he needs to use eGUI UI like this. And he's just going to do this. He's going to return a laid out, boom, bang, bang, boom. This is going to use for item in elms. And the font ID needs to be calculated here as well. Chilling, and this is going to be called laid out, no more A. A laid out is lay out elms of something. Self A as ref and UI. Chillin', I think. And then we do the same for B. And then down here, we do the same thing for B. We'll call this horizontal spacing. And then we'll say vert spacing is rect height over B laid out length -1. There we go. And then this guy is going to look very similar. So this is B laid out rect top. He's still going to iterate over items, but now he's going to say 10.0 and pause here. We're going to invert them. And here he's not going to use the horizontal spacing, but he's going to use the vertical spacing. So we should now see 1, 2, 3, 4 on the top and 1, 2, 4, 3 on the side. Nice. That's not bad. That's not bad at all. And now let's draw like the points on this grid. So I guess instead of drawing the elements directly, we're going to like allocate a grid first, I guess. Who's going to have like X positions and Y positions. I'm not really sure if this makes sense, but I think it does. Right, like, can we get away by just storing the spacing in the start? Maybe, but, yeah, we probably can, huh? So we're gonna call this, like, X spacing and X start, and then Y spacing and Y start. Yup. And then what? What are we doing here? We're saying like function x index to position, and we're going to take in an idx as a usize. We're going to return a floating point pixel positions right to. And so this is like self.x start plus idx as f32 times self.x spacing. We do the same thing for y. Which means that down here we can like create our grid. Something like this. Let grid is equal to grid x spacing y spacing x start is equal to rect left, and y start is equal to rect top. Okay. And then this becomes it iter enumerate. Yep. And we'll say let first is equal to it next unwrap. And the position is grid x idx to pause. And he's going to say first dot, I guess we'll just say 0 here. We don't have to get crazy with it. And this is the element, which is I think the 0 section here, 1. Okay. And so now this is idx and elem in here. And we use this guy directly here. We say grid x idx to pause idx. Okay. He doesn't like this. It's because it's lm idx like this. Chillin'. No? Expected arc gallery found at U size. So what doesn't he like here? Oh, because this is the horizontal position. Oops. Grid x idx to pause. Cool. There we go. And then we can do the same thing here on this. So this is y idx to pause, and here this is grid y idx to pause. It's okay. Which means this needs to be idx lm, and this needs to be enumerated. Okay, so now we can draw some dots in the middle. So I think we go for y in 0 to self b len, and for x in 0 self a len. We just draw a dot at each spot. So we say grid dot x idx to pause x. What do we want to call this? We're going to call this, I guess we'll start with like x idx and y idx to be clear. And then we'll say x pause is equal to this. And y pause is this. And these guys both have to say idx now. And then we can say UI painter, I guess we probably have a painter already. Draw a painter circle filled at this position. And he needs a radius. We'll just say like 3.0 or something. I don't give a shit. And the fill color is, we'll just make it like the text color, I guess. Style dot visuals UI style visuals text color. And I guess we should cache that so that it doesn't like try to call that every time. So we'll say let color is equal to UI style visuals text color. All right. So now we should see a grid that lines up with what we drew, with the numbers that we drew, approximately. Not bad. Right? That's not awful. That does feel like it's approximately tracking. Not bad at all. Not bad at all. And I guess we can assume that there are horizontal lines between all of them. So we have to special case the first element in each one of these. So special case for y 0. So let's start with the x0 special case. The x0 special case is that we basically just do not draw the line. So we do this all a bit here. And then for each of these, we just draw lines. We say painter. We'll call this let prev x pause. Actually, let's just draw the points like this. I think that the double loop makes sense for the points, but not for the lines. So we'll just draw the lines separately. That makes more sense. So we're going to say for y idx in 1 self b len. For x idx in 0 self a len. Yes. We're going to say let prev y is y grid y idx to pause y idx minus 1. Let y is yd this idx, and we'll say let x is equal to the x position. All right, and then we can draw a line between the two. So we say painter line segment who goes from xy to x prev y, and his color is going to be color. He doesn't like this, probably. Oh, because it's into stroke, so he needs a color and probably a color and a size. So UI let stroke is equal to UI dot style stroke. Where do I get a stroke? With just a width and a color. So I guess we'll just make one. So we'll just say stroke new, and he's gonna have maybe a. Let's say that the circle size is gonna be bigger. We'll make him 10, and we'll make the stroke 4 or something, so that the circle becomes an obvious visible thing. And his color is gonna be color. And here we can just say here is our stroke. And here we need to call it into, I guess. eGUI pause 2 is not. Oh, maybe we have to call it into on each of these. There we go. That should give us vertical lines. Solid, not bad at all. And then we can get our horizontal lines, which is going to be the same thing, but he's going to loop for x in a.len, and he's going to say prev x is x, 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 which was Vin Diesel's movie that wasn't Fast and Furious. Triple X. I think I wasn't allowed to watch that one when it was before my time. But I thought he was so cool at that point. I still think Vin Diesel. Well, I don't think Vin Diesel's cool, but I love Fast and Furious. This is wrong. What the fuck have I done here? I guess it's also silly. We can just draw one big line. I'm realizing now. We don't need to draw several line segments. We can just draw one big ass line, because it'll just go through the circles and that doesn't matter. So that's actually way fucking easier. Way easier. Way fucking easier. So we iterate over y, and we just draw one big x line for each of these. So we'll say let x start is equal to grid x idx to pause 0, and the let x end is equal to grid x idx to pause self a dot len minus 1. And then we just draw a thing from x start to x end, and I guess we need the y is equal to grid y idx to pause y idx. Okay. Okay. So now we've drawn one big ass line, and since it doesn't matter, there we go, and we can do the same for x. We don't need to do the stroke thing again. X goes from 0 a-len. X, this needs to do swap everything x and y. This is b, and this is x. There we go. And now this is y start to y end. Hell yeah. What are we? We're fucking an hour 20 in, and maybe we have a grid now. Hell yeah, baby. That's just feels good though. I like it when this works. Okay. So now we have to do the part where we're actually visualizing the algorithm in some way. So we're going to have to get the diagonals, I guess. So I think the do the diagonals come from the algorithm or what? Let's think about this. So what am I even trying to see on here? I didn't ever really clarify that. I guess I want to draw on top of each of these lines which path was taken for each point. Like, how did we get to each node on this graph? Because we take like the shortest path to each point, right? So like to get to like this BB down here, he's always gonna come through this diagonal, I think. Because it's always a shorter path than if we come from here to here. So probably at each step, probably for each level of D, I can kind of see where we're at. And for each level, each K, I can see where we came from. And how do I show that on the graph? I guess for now, let's just color the current DK position. I think that's probably the easiest thing to do to start off, and then we can kind of iterate from there. So at the top, let's just make a little button that says next. And we can say if he's clicked, we'll do something, but for now, let's just kind of like put the button there and make sure that everything else looks okay. Yep, except now, unfortunately, that button's overlapping with everything we just drew, which is a pain. Because I think that I'm using like the wrong rect getter here. Available rect. How much space will still be available after panels are added? This is the background area, what eGUI doesn't cover with panels, but may cover with windows. This is the area which windows are constrained. How much space is used by panels and windows? I see. How much space is used by windows? So I want to do like... I need to like subtract the used area or something. Is it... What's like... How do I get like the remaining area on screen? How do I get the remaining area? Allocate exact size, allocate rect, ignore the layout of the UI, just put my widget here. I guess that's not what I want. I want like reserve this much space and move the cursor. Is there like what's like the available rect stuff? Available. If layout does not wrap, this will turn the same thing as available size. The available size at the moment given the given cursor. So maybe I want to do like available size instead of available rect before wrap. And then I want to like allocate a UI with size. Allocate exact size. Here we go. Yeah. What is sense here? Yeah, okay. The response rect will be larger, blah, blah, blah. Then probably things that are allocated after. Yeah, that seems reasonable. Allocate space. Reserve this much space and moves the cursor. That seems more like what I want. Yeah. Okay, so we say allocate space given the available size. So say available size is equal to this. And I guess we just say, I don't really care what you sense. I don't give a shit. Available size, yep. Oh, this allocate space does not need the sense thing, okay? And then everything else should just continue working. Okay, let's try that. So now hopefully the button is like above the graph instead of inside of it. Still inside of it, which is annoying. Reserve this much space. Move the cursor. And I guess available size, given the current cursor, how much more space can we take out without overflowing our parent? So why the fuck? What am I missing? Like, this rect that we're getting should be relative to what we've already put here, which is this button. Oh, because we're still calling this UI allocate UI rect? Oh no, that seems right. But I guess we probably don't need to allocate this UI anymore because we just have the rect. That was kind of a silly thing to be doing in the first place. Does that fix it? UI stuff is such a pain in the ass. Okay, fuck it. I think we're just gonna leave. I'll fix this off stream. I don't really care about this. It's fine. Because we have to make progress. We have to make progress of showing. At the very least, let's just show the current node. So you can say lib diff lib. And let's just say we'll get some debug info. So we'll say diff algo debug info. And what is he going to have in him? Pub struct diff algo debug info. And for now, we're just going to say x and y. Where am I currently? So x is derived from, if I remember correctly, d and k, you can determine x through this. So I guess let's just split that out. This is my x. And so I guess this x is going to come from, we don't have to pass in d and k because it knows where d and k are right now. And so now we just return that. And so now here we can say let mute x is equal to self x. This. So diff algo debug info. X is self x, and y is x minus self.k. X minus self.k, and here this is x and y, like this. Okay. These need to be I64s, I guess. And then here we'll just say x is x try into unwrap, because we shouldn't ever have x's or y's that are not valid use sizes. This needs a semicolon removed. This needs to be mutable, I guess. And this needs to be mutable. Even though technically we're like getting values from the trace that aren't mutable, it's like we only have a mutable API because that's the only case where it was used before, and that's fine. So this guy now, he's going to store the algo inside of him. And he's not going to do this like stepping shit here. So here he's going to say, here is my algo. And if the button is clicked, we're going to say self algo step. So algo needs to be stored here, which means that algo needs to So the problem here is that the algo is going to be holding on to these references to A and B, and that's annoying as fuck. Because Rust doesn't let me do that. Rust is not like that at all. But we are just going to fucking lie. Can I... What's this? There's something to do like pin here. You can like pin stuff. You can say this is like stored in memory. Don't fucking worry about it. So you can like construct these guys by pin p as dref. So pin, I constructed pin p out of this guy. So we're gonna call these like pin rc. And use stood pin pin. And I'm not like 100% sure I'm using this right, but I don't really give a shit. So let a is equal to pin new unchecked a. Something like this. Let b is equal to pin new unchecked b. And then now that these are pinned and Rust knows they're pinned, you can do like does this diff algo have to hold A and B? Maybe we make this easier by passing in A and B all the time. Then we don't have to do any like bullshit. Okay. So this is like gonna have like this. We don't store A and B, and then maybe here we take in A and B every time we step. Uh-huh. And that will just make my life way easier. Way easier. Okay, so here we say step with A and B. And in eGUI, in our main thing, we now don't have to do any bullshit here. No bullshit required. Although now you technically have to worry about what happens if somebody passes in different A's and B's every time, but if they do that, they can go fuck themselves. You know? You know? And they is me, so even better. I can go fuck myself. Okay. So now every time here we click, and then what we're gonna do is we're gonna color that specific point green for now. So I guess color is going to be, this is for the circle, so we're gonna call this circle color. Actually, we can just call it color, and then here we're just gonna say if x idx is, first we're gonna pull the debug info. And we're gonna just say if x idx is equal to debug info x, and y idx is equal to debug info y. I guess technically you should do the y first, so that like the branch prediction is going to predict true for the first thing. I don't know if that's how this works, but it does seem slightly more reasonable. He doesn't like that these are private fields, so they can be, slap a little pub on there. And this should be equals equals. And then we'll just say, we'll make it green or something. Uh-huh. Yup. Yup. And then we have to make sure that we draw the lines actually before the circles because we're going to be, these lines are going to be like constant color. And so if we want the green thing to go on top, we have to draw it after, I think. I don't really know how eGUI like pipelines these things. Like, I don't know if it's like, if it decides to like draw everything at once in the GPU. Slapping a next on there was unhappy. Surprise. Diff lib 274. So he doesn't like this. What? Which one of these didn't work? 274. So this Y value didn't convert correctly. Okay. Let's just, for now. First, let's cargo test this to make sure that, like, the algorithm is still running the way we expect, that we didn't, like, fuck something up. And I guess this is why it's good to do this visualization, because I clearly don't understand something correctly. It's possible that they are iterating invalid points on the graph. Or they being me. Okay, so for now, let's just make these I64s. And then we can do this comparison in here with I64s. So debug info.y as usize. I know that that's not going to correctly convert, but it also won't, the equals comparison won't work out if anyway, so it's fine. Like we're technically casting an I64 to a, like we're truncating or something, but it's fine. Assertion failed. K is greater than or equal to negative D, and K is less than or equal to D. Okay. Interesting. Oh, probably because we can only do this. We're probably not allowed to call this if we are finished. Right, so we're gonna say let finished is equal to we're probably gonna have to store a finished state. Or maybe we'll store this as, yeah, we'll say finished is bool, and finished will start as true, false. And so we're gonna say if this is clicked and we're not finished, and we're gonna say if this is equal to algo action, oopsies, diff algo action finished. We'll say self.finish is equal to true. And then we're only going to get the debug info if we're not finished. Then we don't have to worry about like validating and stuff. Okay. Still doesn't like that. 175. Can we run Rust backtraced? So this is coming from 134. So we're even doing, it's even if not self-finished, the debug info is failing. Oh, because this stuff moves forwards. No, if... Seems like it should always be valid. Oh, because we have to do this like fucking decay adjustment here. I see. I see. I guess we can just do it again down here. Well, that's doing some unexpected shit, for sure. Jumping right down to the bottom immediately. I think it may be off by one. It might be off by one. We could also try a more interesting... We could try give it a more interesting set of things to render. So here, we'll just give this, like... let's give it something, like, completely unrelated to each other so that we can watch it step through each point in the graph. Interesting. I don't know what the fuck it's doing, but it's not what I expect, that's for sure. It's like only working on the diagonal, which is not reasonable. Okay. So it must be related to this debug info gathering. But unfortunately, I think I have to go. So, thanks for watching, guys. If you like what you saw, I stream most days around 1 or 2 o'clock Pacific time for 1 or 2 hours. Right now we're working on this like diff algorithm. We're also working on like our Git GUI, our terminal emulator. We've done some like operating system stuff, neural networks, web dev, whatever I feel like. That's kind of like what's going on this stream. We'll probably be back at this a little bit more tomorrow because we're not where I want to be, and I have to cut it short, unfortunately. But yeah, there's a YouTube link in the Twitch description, and in that YouTube, there's playlists for all things we've worked on, and there's also a GitHub link in the Twitch description where there's like code for the various things that we're working on as well. If you're watching on YouTube, there should be a Twitch link in the YouTube description where you can swing by, say hi. Apologies for not getting where I wanted to go, but unfortunately, we have to cut it short. So we'll be back at it tomorrow. Thanks for watching, guys, and I'll catch you on the next one. Bye!